Hi folks, let's do problem 4 now in module 3. This problem is an interesting problem because it allows us to do some very quick analysis of two data series, X and Y. So we're going to be looking at this data. It could be time series data, or it could also be any other form of data that you want. But the important thing is that there are two series and that we believe that there's a relationship between series X and series Y. So how do we do that quickly, and how do we determine what the relationship is? The best way to do that is to very quickly create a scatter diagram of the data. We're asking the question whether there's a linear relationship between these two variables X and Y, or there's an exponential relationship. So let's grab the data quickly. They had 78 data points, I believe, observations. Let's go to Insert, let's go to the chart area, and let's find our scatter diagram. And here's our scatter diagram. One dimension on one axis, another dimension on the other axis. So this is X, and this is column M, and this is Y, and this is column N. So we see that there might be a linear relationship or some sort of a relationship between these two data series. If I right-click the data and I add a trend line, then I can pick the trend line that I want. Let's start with the linear trend line, which is here, the default. Let's also go down here and say I want to display the equation, and I want to display the R squared. R squared is a measure of correlation in the linear correlation in the data. So now let's go to our chart. Let's maybe make this a little larger so we can see it. And here's our relationship, that there is a relationship between X and Y that has a constant and a linear relationship with a coefficient, this is called a beta coefficient, of 4.2236 times X. And there's a linear correlation of 0.6053. And of course, we can change that, and we can do the very same analysis by looking at a exponential relationship. And this is where we get these results, where we have the E, very important constant in mathematics, Euler's number, and the base for the natural logs. And if we want to calculate y, we simply put in an x value for here, and we determine a y, and we can see that there's a slightly less robust relationship, correlation between coefficient of determination between x and y. So that's the first part of the problem. The second part of the problem is about calculating values, and in particular I want to calculate the value. Let me move our chart that we got here. I want to calculate the value related to a y, the result of a y, the dependent variable, with an independent variable that is 50,000. So here is the mathematics associated with the linear relationship. A little bit more difficult for the exponential relationship. Here we have the constant that we got above, 70,459, and we're going to take E, and the value for E is, the exponential value for E is 3e minus 0.5x. So 3 times e minus 0.5 suggests that we have 3, and we move the decimal place to the left 5 places. So that results in a value of 1, 2, 3, 4, 5. decimal place here, here's 3, and of course that's multiplied times x, 50,000, and here's the value we get. A very quick way to be able to do very fast analysis to see the relationship between two different variables. That's the end of problem 4.